I'm Pellegrino, and today I'm going to be talking to you about big data. This again is another video in which I'm going to be talking to you about the things that I studied here in the University of Glasgow. In this case, it's big data. In this course, we took a look at the foundations of the big data systems that are currently being used in the industry. Some of these systems are even outdated now. However, the foundations still remain. We reviewed them from an academic point of view, by reading the papers that were produced by the people who built them. This is going to be a short video, since most of the time we spent was discovering the motivations and design decisions behind the systems. I'll put the links to all the papers we review in the description box for you to read them. Starting with the Google File System. This was the first distributed system that Google created to store all the information they manage. It has since then been replaced by Colossus. From there, we jump to the Hadoop file system, or HDFS, which is again a distributed file system, in this case inspired by GFS. As I mentioned earlier, we started with the foundations, and that was the version 1 of HDFS, only to see the difference with the second version. Once we learn about HDFS, we learn about its companion, the programming model called MapReduce, which is a useful technique to process vast amounts of information in a distributed way, taking advantage of having lots of relatively cheap computers. I made a whole video dedicated to MapReduce. You can check the link in the description. However, MapReduce is somewhat outdated too, and it has some limitations. We then review another more modern approach to work with big data problems, using Spark. Spark is a framework from distributed computing that allows us to specify transformation over a dataset without actually doing them right away, but in a lazy manner. Spark has its foundation on the concept of resilient distributed datasets, that is, read-only collections of data distributed over nodes in a cluster. I'll make a video about Spark in the future, so definitely keep an eye in the description box. Both MapReduce and Spark run on top of distributed file systems. After learning about these two processing approaches, we went on to learn about more different ways of storing information using distributed NoSQL data stores, like Bigtable. Bigtable, which is another of those Google creations, is a distributed storage system for managing structured data that is designed to scale a huge size. That's literally the first line in the paper. And that's about it. I mean, it's way more complex than I'm making it sound here, but I won't go into details. Again, we briefly saw an open source version of Bigtable called HBase. Finally, we review Cassandra, another highly distributed data store, and its approach to decentralize the knowledge that the other approaches had centralized in a master node. Another interesting thing about Cassandra is that it makes it easier to work across data centers. As for the practical side of things, we did a couple of exercises, one using MapReduce and the other one using Spark. All of this in a school-provided cluster. Both exercises involved calculating PageRank of scores of some Wikipedia articles, as well as preparing the data to be analyzed. As you can probably guess, all of these systems involve coordination hell, as all of them are distributed and hold redundant copies of data. Some of them not only in a single cluster, but across the entire world in several data centers. And that was pretty much it. I mean, for all the systems, we reviewed the main components that form them, whether they be data nodes, server nodes, master nodes, worker nodes, or whatever they were called in each implementation, as well as the basic techniques that powered their performance, like LSM trees or Bloom filters or SS tables, as well as some of the tools that they use to make them resilient, like writing to logs or creating checkpoints. This was one of the most interesting courses, regardless of it being very academic or very theoretical. We did have some practices, as I mentioned before, and I got to try Scala, which is a very interesting language. So that's it for me, at least for this video. There is one more coming, which is going to be about machine learning. And if you find this video interesting, and if you like them, just give it a like. Subscribe if you haven't done it yet. And I'll see you in the next one.